All right, hey folks, thank you for joining us this afternoon for the Digital Engineering and Advanced Manufacturing Mission Domain Engagement. I'm Rich Tempalski, the Department of the Air Force's Chief Modeling and Simulation Officer and the Chief of Digital Engineering in AQ. I'm pleased to share the virtual stage today with some of industry's most remarkable technical innovators. They are from companies that are leading the world in research and development of capabilities and are revolutionizing the way we think and fight in every mission domain. Now, how I'm going to be setting this panel up is I'm going to go through and give a quick introduction of each of our distinguished panel members. And after my introduction, each of them will have the stick for opening remarks and what they bring to digital engineering and advanced manufacturing, followed by answering some questions that we have prepared for them. For the audience, if you have a question, please don't use the chat. Use the question and answer box at the bottom of your screen. All right, first up is Mike Atwood. Mike is Senior Director for Advanced Programs at General Atomics Aeronautical System. He is responsible for technical and programmatic oversight of new aircraft development. He and his team are developing the next generation of airborne recovery small unmanned air systems, with those air systems leveraging distributed swarm technologies. Previously, he was responsible for designing low observable aircraft in support of the U.S. Navy's unmanned carrier launched airborne surveillance and strike program. He has 17 years at General Atomics and is a graduate of California Polytechnic State University. Welcome, Mike. Anything you'd like to add?
No, I think a great introduction. I think to easily surmise that up, best job in aerospace. So thank you.
All right, next we have Dave Duggan from L3Harris. Now, Dave is president of Precision Engagement Systems for L3Harris Technologies, with his portfolio consisting of unmanned aerial systems, precision munitions, assured position navigation and timing, and advanced fuses and electronic warfare. In addition to his current role, Dave was also president of L3 Unmanned Systems for more than a decade and is a graduate of the University of Texas at Arlington. Thanks for joining us today, Dave. The floor is yours for opening remarks.
Okay, do you want me to go first? Opening remarks, Richard?
Absolutely.
Okay. So I guess I'd first like to start out by thanking you and AFA for the opportunity to participate in this panel. I'm honored to be a part of the dialogue with some pretty smart people on the phone here. I'm personally passionate about the power of digital engineering, and I'm very energized about how digital engineering is impacting L3Harris. So I thought I would focus my opening remarks on what we're doing in L3Harris with regard to digital engineering. So our company is fully embraced and is heavily investing in the digital transformation. Digital engineering affords our company the ability to dramatically accelerate product development using much smaller development teams than historical norms. We've proved that on many programs. And while many sectors across our company here at L3Harris are at different stages of maturity, I can say that we've been on this journey for some time, and we're working on building a new kind of non-traditional prime that's focused on advanced mission systems and advanced weapon systems, utilizing digital engineering and agile development principles in our design, security, program management, test, manufacturing, and overall program lifecycle planning activities. In my opinion, the ideas behind digital engineering are not necessarily new. Our journey started over 2 decades ago, where we implemented and used an all-digital development environment that enabled a single engineer to literally take a design from concept all the way through hardware in the loop test, all from a common all-digital development tool suite. High fidelity, physics-based, detailed digital models of our systems and subsystems are not new, nor are the advanced computer-aided design tools for extremely high fidelity 3D CAD modeling with automated connections to advanced analysis tools like finite element analysis tools or CFD analysis tools. Arguably, what is new is the rapid advancement of processing technologies like GPUs that enable us to run these tools at unprecedented speeds, literally from our desktops. And so in my mind, this has opened the door for advancing the all-digital environment to the total system lifecycle. We use digital engineering along with the agile development processes to quickly develop new products and capabilities, The systems engineering teams in my particular sector have generated complete system models in an integrated data environment with threads to requirements, test, design trades, and design engineering tool sets. We're also adding models in these environments for areas that include verification and validation, risk management, capturing cost and schedule, and program management, as well as automating tracking and management of metrics like performance parameters, key system attributes, and technical performance measures. To realize the full benefit of digital engineering, we've developed and deployed an underlying knowledge-based product development process that follows the basic principles of early learning and leveraging that digital thread combined with early prototyping and experimentation. It starts with capturing KPPs and ConOps, then allowing our engineers to quickly perform trades in the digital world, supplemented by prototyping and experimenting for model validation. These trades, experiments, prototypes close knowledge gaps in the design of systems and subsystems while focusing on mission performance. Our engineers start with a wide aperture of possible solutions rather than a point design and follow a process that quickly learns the best solution over time through high fidelity simulation and early experimentation. As our teams trade designs and perform analysis and engage suppliers and create prototypes, we capture all the information in our integrated data environment, which acts as the single source of truth for our system architecture and designs. We have a suite of tools for implementing our digital engineering and model-based systems engineering activities. The tool suite provides the backbone for the integrated data environment, which I mentioned earlier, and includes modeling languages as well as framework templates. I think all the things that you'll hear about from my colleagues on the panel. The tool suite also has plugins available for integration with processes, including requirements, management, and systems design. Any desired documentation can be generated directly from the integrated data environment in several formats. And it also allows for common internal cloud interface for multiple people to work on the same model at the same time while maintaining strict version control. Last, I'll say we work very closely and as a trusted partner with our government customers in this new paradigm. We found that success requires both contractor and government customers need to approach the problem in a like-minded manner. Given our understanding of the threats our nation faces, as clearly communicated by our customers, speed is everything. And we believe digital engineering and agile processes that support it provide the tools needed to develop and deliver new capabilities at the speed of relevance. So that's kind of the thumbnail of what digital engineering looks like in our organization. And again, thank you for the opportunity to be on the panel.
All right, Dave, thank you. Also on the panel, we welcome G.J. Miller from Boeing. G.J. is Chief Engineer at Boeing on the T-7A Red Hawk program in the Advanced Pilot Training Program of the Strike Surveillance and Mobility Division. He is responsible for all the technical products and activities throughout the product lifecycle, including requirements definition, production, test, certification, and post-delivery support. GJ has more than 30 years experience at Boeing and a bachelor's in aerospace engineering from Parks College, as well as a master's in engineering mechanics from Missouri University of Science and Technology. Thanks for coming, GJ. Would you like to add anything?
Yeah, thanks, Rich. By the way, that was a great intro by Dave. And, and I just want to put some special emphasis here. Dave hit on a point and he said that this is not the beginning. This is not really a new thing. We've been on this journey for a long time. And I will add in, we also here at Boeing have been on this journey for a long time. I go back 20 years. I spent 18 years in Phantom Works. I've done a number of systems from, original concept to a hard problem to design, build, and test. And over those 18 plus years, we've really refined the tools, processes, and methods that Dave was talking about that have now since come into the lingo of digital engineering or model-based engineering. You almost have to have a definition sheet. Lots of people call it different things, but I will say that one of the rallying features of Dr. Roper's two white papers, or maybe a red paper, if you want to call it that, was that it did start to establish some of the governance, like you were mentioning earlier, around what is model-based engineering, what is digital engineering, and more importantly than anything else, I think he was very succinct in explaining why we are doing this. Dave touched upon it, but I want to hammer it home. If you look at our country and our industry, we have to be able to gain the advantage and outturn our adversaries. We once had that, and we lost that. We can't stand development cycles that take tens of years, because quite frankly the threat has morphed and changed by the time we produce a product. So government and industry together, we have to figure out how to get that down into the 3-year or 2-year time frame. Once we get there, then we will gain the upper hand again, because we will be able to react quicker than the adversaries can put new threats out. That's really why we're interested and invested in this 20-year journey. I'm extremely proud to be here today, and I thank you for the invitation, because here in Engineers Week, I get to represent the great men and women engineers of the ET-7A Red Hawk. I know this journey. I know what they're capable of. And, the folks on this panel with me, you're going to hear a similar story. This is the future now, and we will never go back and do it any other way. So I'm just really proud to be here, and I thank you for the opportunity.
Thank you much, GJ. And I'm also pleased to welcome Renee Pasman from Lockheed Martin. Renee is the Director of Integrated Systems at Lockheed Martin Skunk Works. She leads strategy development as a portfolio management in a tri-site team focused on the execution of classified programs. She has previously served as Director of Mission System Roadmaps, being responsible for the execution of multi-interrelated projects in open system architecture, cyber, data links, aerospace integration, and electronic warfare. She has a bachelor's and master's degree in aeronautical engineering from California Polytechnic and a master's in business administration from the University of Massachusetts in Amherst, Massachusetts. Thank you, Renee, for your time today. Is there anything that you would like to add?
Yeah, I mean, I think you heard, thanks for the introduction. One of the things that I'm currently doing, because I would argue I probably have the best job in aerospace. I can't talk about everything, but one of the things I can talk about, and I'm really excited to talk about with this panel, is the investment that Skunk Works is making and taking all of the lessons learned that GJ and Mike and Dave alluded to in terms of the last, 15, 20 years of technology improvement that are wrapped up in digital engineering, digital transformation, digital, whatever you want to call it. Like GJ said, definitions are wide ranging, and really applying it to our programs, because it is in the application of it that all of the details that are super important, both in terms of how can we best leverage, yes, to bring capability to the field quickly, to be able to respond to the threat, but also I think a very important part and a unique ability of industry and the industry partnership with the government is how can we do so very affordably, so that we can truly focus in on providing all the capabilities that our warfighters need in the time frame that they need it, and within the budget constraints that we have, so we can truly bring the full power of all the industry partners and opportunities to bear and bring that best of breed innovation across the entire industry base for our customers, for the warfighter. And so I'm very excited that for once I have something that I can actually talk about publicly in terms of the application of all of those technologies, and whether it's everything from things that only I think get excited about, like data architecture and reference architectures and all those types of things, and then the actual like end product of those applications, of how much more, which lots of people get excited about, of how much more quickly can we get those capabilities out to the field. How can we collapse those timelines? How can we collapse some of those budgets to be able to give that not just capability, but also that strategic flexibility to the warfighter in an interconnected, all-domain kind of world across all of the domains of air, space, cyber. And that is, I think, to me, one of the most exciting things from a digital engineering perspective. It's more than just engineering. It's more than just manufacturing. It's supply chain. It's production operations. It's finance. It's all of us working together as a single team to deliver that capability at the speed of relevance and at the affordability targets to really unlock our customers' mission.
Absolutely. Now, Mike, we moved pretty fast through the questionings. Is there anything that you wanted to add as an opening remark?
No, I think all the comments are, like GJ said, are going to be very similar. I think GAs have a kind of a unique posture because the UASs that we've deployed for the last 20 years or so have been in all electric aircraft and have had this ability to collect a lot of data that traditionally would have gone in the pilot's brain. And I think what that's done, kind of like Renee talked about that endpoint, we've actually started with the endpoint in our digital engineering and worked that back to the physics-based models. And I think that's allowed these very applied digital engineering, digital thread use cases to really be applied to the actual warfighting to get the highest yield. And I think Roper brought that all the way back to the beginning, and he talked about the context of how we're going to do it. And now it's up to us to kind of harmonize both the birth and the operations together and connect it through the middle with a strong governance from the Air Force and the other boards that are out there. So very excited. I think we're at a point of renaissance in all of this digital engineering. I agree with Dave that a lot of the tools already exist. We have them. We just need to start using them. And I think there was another theme there of integrating industry together, integrating the government together, better together. I'm really excited to bring kind of the ideas and collaborate around them. So GA is very excited to be a part of that.
Excellent. Just moving on. Once again, I'm pleased to be able to moderate this event with such a distinguished panel. And we're going to move on to the questions. My first question is going to be for the entire panel to answer. And it is can you each provide an overview of how you are incorporating digital engineering practices into your company and how this will benefit the Department of Defense? We're going to start with General Atomics Aerospace. Mike, you're up.
Yeah, I think to kind of jump off the comments that I just gave, the digital thread has really been the focus more than the digital twin. GA has been very fortunate. We've made 63 different combat aircraft over the last 30 years, 6 million flight hours downrange. And what's happened is we've been able to look at digital engineering through the lens of kind of machine intelligence, AI, and the systems engineering that comes with that. So I wanted to start off with a kind of very applied use case and then walk through how digital engineering is applied to that. So our Gray Eagle product line, the product line used by the Army, experienced a series of gearbox failures in the field that none of the SMEs could figure out. It was a combination of a bunch of different variables that were somewhat non-deterministic. So we started using machine learning techniques to data mine all the data collected on the aircraft. And what that did is it built a physics model based on statistical relevance that we were able then to compare to the actual physics that we expected. And we essentially did a gap analysis on those two and understood the difference between how we thought the system was going to behave and how it was behaving. Once we were able to verify that analytical twin, we were able to finally roll in condition-based maintenance. We were able to exceed our availability targets for the aircraft, reach about a 92% mission capability rate. That happened about 4 years ago, and I think that implanted an anchor in the upper leadership of the value of digital engineering. Because it's one thing to have the tools, and it's one thing to work with it at the tactical levels, but unless it ties to the value proposition of how we operate these aircraft, it's hard to get it to stick within the frameworks that a big business works within. So with that anchor, we started working on model-based design, multidisciplinary optimization, and looked at how those early models could inform the sensitivity analysis for the O&S cost. And so our latest generation of product, known as the Sky Guardian aircraft, which is an MQ-9 Reaper-based product, has enjoyed the value of that upfront digital twin that we're now just seeing the initial deployments of that platform, and we're able to curb off those problems we saw with the legacy platforms. Now, one last point I want to make, once you've made all these models, validated all these models, now we can share this with our industry partners. L3 Harris might bring a very capable ELINT system on board, and we can plug that SysML framework in using open standards like UCI and OMS and OCS and rapidly integrate new capability. L3 has done an amazing job with their RDES product line. We recently deployed that overseas and achieved great success in the ELINT domain on the MQ-9 Reaper. So again, it's about bringing that collaboration through a strong use case, applying model-based systems engineering principles to solve incredibly hard systems engineering problems.
All right, how about things at L3, Dave?
Sure. So I gave a few kind of a broad overview of what we're doing in my opening remarks. And so in general, what I would say is, speaking specifically about the business area that I'm responsible for, I would say our digital engineering journey really started, well over 20 years ago. And you're leveraging the modern tools at the time, focused on developing as high a fidelity physics models as we could, right, to model these, systems that we were developing, both unmanned and weapon systems. And, taking it from, using the tools to, simulate and model in a high fidelity manner the Aero system, all the way to punch at a button and getting the actual target embedded code out, right? And so, some of those early tools that have continued to evolve over time, as we've evolved the business and expanded the use of digital engineering, more recently, some of these, model-based systems engineering methods have come along. And so taking this core infrastructure, this core development environment, and extending that to the systems engineering process, right? So now the requirements, database is all linked into the model, if you will. So all, kind of staying up with the tools and the ideas, right, as they've evolved is something that we've done. Different parts of the company are certainly at different levels of maturity, but at an enterprise level, we're investing in digital engineering and adopting the capabilities across the business. And one of the things that L3Harris has done is implemented what they call startup assist resources, right? So these are things like training processes and tools, right, to provide to businesses that are starting to enter digital engineering, if you will, as well as subject matter experts that can come and kind of teach, right, the businesses that aren't necessarily as adept in the ideas behind digital engineering, teach them what it is, help them understand how to best apply the capabilities and when, right, it's appropriate to start applying them. And so, a lot there. I wish I could go into real specifics on the programs, but can't. Kind of leave it at that. Yeah.
Thank you much. GJ, I'm sure we're looking at some similar philosophies. Does Boeing have any additional practices?
Yeah, and here's the real great thing about the T7 is my co-panelists have mentioned multiple times here. We all do a lot of work that can't be broadly shared. However, T7 can be and is, and really we're trialing out a lot of these combined new methodologies in a very open environment. And we are an advanced pilot training system where we're an aircraft and a ground system, a simulator system to go along with it. And we don't have as many of the security concerns or constraints. So we can be very public in sharing what it is we're doing and quite frankly, what's succeeding and what are the areas that we still have work to go. And we're excited to do that. We just started our build, and a lot of the new methodologies, tool suites, and I don't want to make this about tools. They're being applied now, and we're going to be able to learn that. And also, one of the areas that we really look forward to on the digital twin side is we're going to have aircraft in service, and we're going to finally see application of these new practices applied downstream out in the field. We're all familiar with the idea of a digital thread, but we will have a digital twin for every tail number. and we'll be able to understand the condition of every aircraft in the fleet. And oh, by the way, every ground-based training system, every simulator also will have that information. And that is going to be just break the norm on how we operate and learn from that data. Mike touched upon an important point. If you don't mind your tails and bring statistics against this, you're going to have the potential to run into trouble. So Mike's case on the gearbox was kind of an example of these, say, -2, -3 sigma things that could occur. It's sort of the perfect storm example that the technical SMEs never stacked up as something that was possible. And part of the learning that we're doing right now and advancing model-based definition is bringing some of that AI and those data analytics in, so that even though the models and the physics-based models are predicting success, we still want to be able to mine those 2 and 3 sigma conditions and be ready for that. And part of that is margin management and robustness that you bring into your design, and that factors in. But we all know we have those challenges on cost and weight and performance. So, margin management is very important. It's an area that we expect to see. And we're actually going to have hard visible data with the T7, where we're going to be able to use those as use cases and share with our government partners and customers, and really shape how we leverage the advantages out of that digital twin. Mike mentioned earlier, the idea of a digital thread and digital twin's been around. We've had that. It's just we haven't quite crafted how we make use of that information. It's a gold mine. And what we're going to be able to do on T7 is be able to show that and learn from it. And that's going to move the ball down the field.
Yeah, I'd have to agree with that. Now, Renee, you're a leader in development at the Skunk Works. How do you drive DE for Lockheed Martin?
Yeah, I think one of the interesting bits from the Lockheed side, everything GJ and Mike said is incredibly true, and Lockheed's portfolio across the entire corporation is very broad and very deep. So whether it is the specific application of AI and machine learning to C-130 maintenance, of being out in the field and seeing those 2 sigma, 3 sigma cases, and thinking through back, how does that impact new development of new clean sheet programs? Or for that matter, I see there's a question on, using digital engineering to quickly iterate designs early on, and linking all of those tools together, and then feeding that information from completely different platforms into there of what is it that you actually should be worried about, where is the risk, understanding that design space early. I think by leveraging the breadth and the depth of the entire corporate portfolio, it's giving us some very specific insights of all of the various things that could happen. It's a mountain of information, and really thinking through what needs to be applied early and when, I think is part of the enjoyable part of the challenge, particularly then from a Skunk Works perspective, thinking about those new development programs and how do we leverage all of that data, but also how does it get leveraged into our existing programs for that future capability, and getting that work done quickly. I think one of the key things, and I'll bring up a Cal Poly San Luis Obispo model that Mike will probably recognize, right? Learn by doing. I think that is one of the key things. There is so much we can talk about with open standards and tools and this and that and the other, but it's in the application that we figure out what is actually of most value, what has the biggest impact on the warfighter capability, what has the biggest impact on the affordability. And that is, I think, key, both learning on the industry side and then learning with our government partners of, where do we work well together, where can we work together better, and where can we truly focus on that partnership and delivering capability. And it is in the doing that there is so much learning, and there are so many opportunities. Dr. Roper gave some specific examples in his red pill paper, But there's a lot of work that hasn't necessarily been brought out to the fore. And to GJ's point, it's really important to share that so that we can all collectively make progress across the entire military program opportunities.
I agree. I want to say also thanks, panelists. I appreciate those answers. Also, on a side note here, we are doing really well with time, so I appreciate that as well. For the next set of questions, we are going to be asking the panelists individually. So this first one we're starting out, and this question is going to be for you, GJ. And the question is one of the precepts in the Air Force digital transformation strategy is authoritative virtualization. How are you approaching an authoritative source of truth in your programs?
Yeah, okay, that's a great question, Rich. And I want to start off because I'm not sure everybody on this call understands what authoritative virtualization really means, but it really is the end goal of what we're doing with model-based engineering or design engineering. And if you can imagine, it's really a destination. So once we get to the point where our digital models and however we represent the various systems of a complex systems of systems, once we have those at such an accurate level, they start to replace sort of the traditional analog building block approaches. So for us, that means understanding how and what makes a validated model. That's really important for authoritative virtualization, because if you can't all agree that your models are quote unquote validated, then you're never going to have an authoritative virtualization condition. And one of the areas that we've moved the ball, and there's many, and I'm just going to cover one that I'm particularly proud of, because digital engineering and that end state of the authoritative virtualization is really a culture change. Sure, we talk about processes and tools and people. People are really instrumental in this. Until they understand and believe that there's a different way of doing things and interconnecting, then we won't wring out all of the savings that the potential is there. So I want to make sure, and one of the things that I am, I list myself not only as chief engineer, but I also consider myself chief cultural officer of the program. And I explain the value and get everybody on board. It's hard to believe, but the idea of having an integrated product data manager, and everybody's going to have a slightly different name of that, but a repository of all of your information that is controlled, and it represents a single condition, i.e. the baseline. That is still a fairly radical view for some engineers. I can tell you 10 years ago, most of my challenges were, please don't take your model-based engineering or your model-based definition that you're working on and pull it off onto your own individual hard drive and go do some things and great work, and then come and push it back into the master repository a month later. Because, and I think we're all laughing because we've all seen that, right? We've experienced it. So, once we made the jump and broke that cultural norm where it was okay for everybody, including your customer, to see an in-work product. So, part of the idea of the tech stack that scares the holy heck out of people is, what do you mean? My customer is going to see the sausage making? And will they be able to handle that? Because that might actually freak them out a little bit. Because, developing a new complex system of systems, the sausage making it's sausage making, right? And, the first time that somebody says, is that peanut butter supposed to be stuck on that chocolate? And isn't there a problem there? As long as we can all work through that single source of truth is just that, and we can deal with the in-work data, then that is going to be a key cultural milestone, because that single source of truth is so important. And what we have seen from a quality of our engineering standpoint is tremendous, right? I mean, and I got a statistic here. If I look at the last 3 programs here at Boeing, that have been model-based engineering programs, they have a 75% improvement in engineering quality. And the question is, well, what is that? And the reason is that single source of truth that is driving all the other stakeholders and users, consumers of those physics-based models, and that collaborative environment where people are then comfortable working with in-work process data and contributing and evolving through it. What the result is, it improves overall quality, right? Because no single person or single group or single IPT, integrated product team, knows all the answers. And when everybody is working in the single source of truth, and that is where they're getting their start from, their requirements, their model-based design, their verification and validation artifacts, their CFD, their global FEM, all of that stuff is feeding out of the same start point. You get such a big lift in overall quality of your engineering. And that is really where we're moving. We see that end state of authoritative verification. And we want to get there. And I think we will all get there on this journey together, but there's conversation that has to occur on what exactly validates any piece of a model. For instance, if I was to go to airworthiness and say, just trust the model, right? Well, you know, that won't always hold water, right? So we've got to bring people along on the journey.
GJ, I'm sorry, with that, I'm going to have to pause and let Mike answer a question here. Thank you.
All right, thanks.
No, that was fantastic. Mike, this one's for you. Technology enabling today's digital transformation is complemented by advances in manufacturing technology. What do you see as the benefits to the integration of digital engineering and advanced manufacturing technologies into your company's operations?
Yeah, it's a great question. And it's, I think, one of the more fun parts of this digital engineering, which is the front end of it, the innovation. I took Learn by Doing from Cal Poly and turned it into Innovate by Integrating. And there's just so much great stuff that's around that we can just integrate together and innovate through. And one of my favorite use cases right now, that is GA is very invested in hybrid electric propulsion technology. And some of the key challenges with that are power thermal management, electrical design harmonized with aerothermal design. Those are incredibly hard disciplines. GJ mentioned CFD, model-based design. Not only do you have to do those things, but you have to co-optimize those things real time. And so we've been looking at doing design-driven model-based systems engineering on additive manufacturing for fan blades for hybrid electric propulsion drives. And so that's been very exciting because what we do is we build an optimizer in a multidisciplinary environment that takes into account the durability and strain criteria of a fan blade, but then also trades the thermal engineering side of it in this ductwork and co-optimizes a flow-through duct with an integral wall heat exchanger co-optimized to the fan blade design. And it's just this harmony of analytical engineering that we can do now. And I think, GJ talked a lot about cultural change. For that structural designer to trust the thermal designer, to trust the manufacturing engineer and share in their craft, there's immense power in that. But it takes a willingness and a cultural change to allow the crafts to merge, and it intensely becomes a systems engineering problem. I think in the back end of that comes the collaboration. You mentioned that word collaboration. And what we're seeing is collaboration across the industry. So I know Dave Stagney from Pratt & Whitney is going to be talking tomorrow. And so we've started collaborating with Pratt & Whitney, and they have brought some amazing additive plastic technology. We thought we were going to make the fan blades out of titanium. I was actually going to run out off camera and grab one of the fan blades just to show how cool these things look. But Pratt came in and said, hey, we think we can do this out of plastic. And that just blew our engineers' mind. And it's that harmony of sharing the CFD, the FEA, all those models holistically to another company, letting their optimizer run on it, come back and share in that data. And then with additive manufacturing, I mean, it is just a fabulous world we live in. I mean, you can dream up a Blisk fan blade that's 40 inches in diameter, and 6 weeks later, it's sitting on your desk. When I was an engineer, that growing up in college in the early years, you would have to machine something, you would have to EDM sync, EDM wire something, you would wait 6 months and you'd kind of sit there and you were very serial. And then that's the last point I wanted to make. Digital engineering allows us to all work in parallel. And we talked about, I think it was Dave brought up the agility and speed that we need to bring, or Rich, it might even been you. We have to speed up the development cycle, right? Our adversaries are absolutely outpacing us right now. And we need to get back into these tighter design loops with more empowered engineers, with these modern tools. And we're so fortunate that the commercial industry has pioneered some of this technology for us. And we just need to bring it back into defense. We need to integrate it in. And I think there's some amazing innovation that we're seeing. I saw some questions about kind of NGAD, future fighters. I think that is a program that will take kind of the grand symphony of everything that we're talking about on this call today and really apply it. And what I like about future fighter programs is it's the Air Force, the Navy, and industry working in a collaborative, trusting environment, which is a new frontier for us, right? It's because we need to bring that speed together. So very excited about those programs. I think most people should kind of look at those and see how they mature over the next decade or so. But I think that's where you're going to see the application and kind of the final use case of the harmony of this stuff.
Thanks, Mike. And actually, this is a good segue into a question for Dave. New start programs have an advantage of being born digital. What can be done to assist existing programs to transform digitally?
So I think it starts with an assessment of, where the juice is worth the squeeze. So specifically, where's a program in its life cycle? And programs that are already well past the development phase and into production and sustainment, might not have, real benefit from moving their total system design into the digital domain. But they might find value in starting new spirals in the digital domain, right? New payload integrations or sensor integrations or, communication systems, whatever the case might be. They might find significant value in moving their designs in the virtual CAD world to leverage things like modern virtual maintenance training technology, right? Which Michael probably knows a lot about. This is something that, so I'm an aerospace engineer by trade, a controls engineer. So when I think of digital engineering, you might have gotten the sense of this. I think high fidelity physics-based models and all those things that go behind, aero control systems. What blew my mind was seeing this virtual training technology that our military training system division is working, and there's others out, in industry doing this. It's amazing, right? Where they're working with legacy programs that are well into their sustainment phases and migrating their maintenance training program into the digital world. And they literally build complete high fidelity digital 3D CAD models of the entire system using, either existing CAD, drawings that the program provides, or if pieces of the system, aren't modeled, they'll use coordinate measurement machines to scan them in to build those CAD models so they can build this complete virtual system. And then the operators use virtual reality headgear to train their maintenance in this virtual world. And it's truly incredible how realistic it is and how realistic those parts are. I know that the operational assessment data that they've collected to date shows that the training efficiency is significantly improved by doing this in the virtual world. And then, so the thought there is, in terms of juice worth the squeeze, extending that into the whole logistics chain. So that they take an iPad with a camera, an operator can scan the system, and it automatically will grab a part, using, automatic detection software, grab a part, tell you everything there is to know about the part, right? It'll link to documentation on the part. It'll pull up maintenance manuals on the part, troubleshooting trees, or even just general information on the part. So those technologies, extending the logistics chain, they easily be extended and probably already are, into the virtual manufacturing process and things like that. So, building an entire manufacturing process and training your operators in the virtual world, is a pretty cool extension of the digital thread, into, programs that have been around for a very long time.
No, thanks, Dave. You're spot on that. Renee, this next one is for you. As the Air Force and Space Force work to shape the integration of digital engineering practices into future acquisition efforts, how is industry partnering with the government to bring this vision to life?
Yeah, and that's a great question. I think the whole idea of partnership, and we've talked about this throughout the panel, right? But one of the things that digital engineering or digital transformation or digital thread, digital twins, one of the things they allow is that better sense of partnership, whether that's on our existing programs that are generating new capability. I mean, there certainly is an element of being able to be born digital in a new acquisition, but even on existing programs for that future work, those future capabilities that get upgraded that need to go to the warfighter, that requires partnership. That requires partnership between the government and the industry, between industry, and also whether on existing programs or new acquisition programs, partnership across the entire value chain of delivering a capability. We're all engineers. We all kind of focus in on that engineering element and the CFD guys trusting the thermal guys. But there's also the engineering tied with the production ops side, tied with the supply chain side, tied with finance, tied with sustainment. And in the new acquisition type of world, bringing all of that in at the beginning, as Michael mentioned, kind of the really interesting part when you're looking through all of those different configuration options and making sure that you're accounting for all the things that are important over the entire life cycle. And that partnership, not just from an engineering perspective, but from all of the functions involved, I think is key. And a key part of that partnership, Richard, to your point and kind of the point of the question, is industry and the government partnering together. To TJ's point about, data in progress or products in progress, really getting that collaboration early in an open environment so that we can ultimately bring everybody's expertise, everybody's perspective on how to bring the solution to the warfighters most quickly, the right solution, and then also for the right price point. And I think that is where we're very excited. I think the industry as a whole is very excited. Lockheed is very excited to really work on that partnership. And in terms of some specific examples, we've been very encouraged with some of the areas on our investments, also on some of the current programs, on great partnerships with different parts of the government as we all try to work through this together, figure out what the best path forward is. And I will also put a little bit of a specific example here to that point of validated models, really understanding how we can improve the timeline for test, for validation, for airworthiness, for mission assurance, because all the engineering in the world and all the airplanes in the world don't make it to the field if we can't collapse some of those timelines more quickly. And I think the digital engineering or digital thread and digital twin are key on that, and really working in partnership with between the industry and the government on how to make significant progress there, I think is a very exciting thing that's coming up here in the next, couple of months, couple of years as we work through some of this and get that capability out to the warfighter.
Thanks right off the bat. As some of these things that you're talking about is actually topics I'm going to bring up during my closing remarks. So I do appreciate that. Now, panelists, we do have some time for an additional question before I do those closing remarks. It's going to be a little bit different. This is more along the lines of a lightning round. The question that we're being asked is really, how does data architect fit into your digital transformation? Now, when I say it's a lightning round, is if you could answer that question in 60 seconds or less. Oh my goodness, that's going to be tough. But if you could do it, much appreciated. If you needed me to ask the question again, please let me know. So the question is, how does data architect fit into your digital transformation? Dave, I'm going to have you start us off.
Man, I'm the way wrong guy to start this lightning round. So So I guess it depends on your definition of data architect. I'm going to treat it as the equivalent of a systems architect working in the digital environment, right? And so it's critical, right? If I'm interpreting the question right, that systems architect that fully understands the digital world, both the strengths as well as the limitations and constraints of the digital world. And I'll just ditto everybody that's talked about validation and model validation, right? Having a deep understanding of where the tools can enable you to be successful and where the tools, right, need further development and further refinement, and where prototyping and experimentation is essential. And so those systems architects, my interpretation of the digital data architect, absolutely critical in guiding the program to make, use good judgment to make those decisions and take appropriate risks in the program.
Yeah, you did a good job there in that 60 seconds. GJ, you're up. And the question is how does data architecture fit into your digital transformation?
Yeah, it's great to be able to draw an architecture of how data is going to flow in and out of your system. But to a couple of the points that we've already talked today, the real secret is connecting dots through a great integrator to get the value, right? So if the stress analyst or the thermal person or the CFD person don't even know each other or know their products, then you're never going to have the connection to have that serendipitous moment. And what we've put a lot of emphasis on T7 is having great integrators. These are people top level that know the whole system, the system of systems, and they can say, hey, Jill, have you met John? You should know each other because your models touch and they're tangential. And so don't take the person out of this. Digital engineering isn't about taking the people out. It's about building the bridges and having control over it.
No, that's right on the money there too. All right, Renee, you're up. How does data architecture fit into your digital transformation?
I think I would say that the data architecture is foundational for all the points that GJ and David, and I'm sure Mike will bring up. Whether you're talking about the architecture for the integrated solution, how does everything actually link? As well as the idea of data architecture encompassing the entire life cycle of a product. And I think that's one area where we really need to leverage the breadth and the depth of all of the portfolios of programs so that it isn't one use case that dominates the data architecture, but that we really focus on that integration across all the elements of a program, because it's those connections that are key. And then also, I think, before we started, you were talking, Richard, a little bit about the government reference architecture, but that data architecture in the sense of how do we collaborate and making sure that when we all say the same words, we actually all mean the same thing. That is foundational, I would argue, for making progress in this area and making progress quickly.
Oh, that's excellent. All right, Mike, you're up. So that's how does data architecture fit into your digital transformation?
Yeah, I liked how you began with the word data architect, because I think what we've experienced at GA over the last 10 years of doing this is it can be an atomic bomb. I mean, there's so much model-based systems in there. You can throw the kitchen sink at it. And if you don't have a defined use case and a defined set of connections, you get lost in the model-based systems engineering. And so I love where Renee went, that digital thread. That's kind of where I started, because it validates that use case and it shows you where those important connections are. So you build that architecture, and then the data architect manages those relationships across that. And then lastly, the data architect works with the data architecture to do governance. And I think there's this theme, government reference architecture, unless we're all saying the same thing with the same type of data exchanges. So I think there's a piece of that answer in everything we've talked about in the session today, but the human element of the data architect, I think, is where we're emphasizing it right now, because they right-size the model-based systems engineering to have the best yield for the type of program that you're on.
I agree, thank you. All right, folks, we still have a couple more minutes left. Is there any additional questions? Let's see.
Yeah, Rich, it looks like we've had a number of questions
All
come
right.
in the Q&A panel.
I'm seeing some now, and I appreciate it. This first question is for GJ, and it's the government pushed the envelope on open standard requirements and IP clarity during the T7 solicitation. Boeing brought digital engineering. What outcome benefits do you envision for the DoD when T7 is fielded?
Yeah, that's, when you think about open mission systems, which was a requirement here, that's going to be so instrumental and key as the product actually evolves. And I see a number of questions down in the chat panel about, where does T7 go? Is there going to be an adversary or a light attack or what? And really, what the government has done has positioned us for the future well, because those open standards are going to allow us to quickly bring additional capability, whether it's LRUs or sensors or whatever the case is, onto the platform and build off of the success that we've had on the trainer version.
Yeah, excellent. I think we have time for one more question. And this question.
I'll jump in there, Rich. I think that cyber question that just came in is a super interesting one. I would say that cyber and model-based systems engineering are kind of at odds right now. We're trying to speed things up, and there's a certain aspect of integrating these systems together that has been extremely problematic with the cyber domain, because the cyber vulnerabilities and the cyber threats are sometimes outpacing it. And so coming up with unique frameworks to deal with this kind of cyber vulnerability, cyber formica, cyber attack, I really think stress our SysML architectures to the point of breaking. The government reference architectures that we're seeing, come out right now that are governed are struggling with those things. And how do we take the wide variety of industry innovation and solutions and compose them together in a way that has cyber resiliency? That is something that keeps me up at night. Absolutely. I think that was a great question that came in.
And just
Thanks,
real quick,
folks.
kind of jumping off that and GJ's point about OMS and the importance of that, I think we share a lot. I think industry as a whole shares a lot about how do we bring together a cyber resilience solution along with a digital engineering solution, along with open architectures. And I think there's probably some very good lessons learned and collaboration between some of the mission systems open architecture standards work that has done and how they've solved those problems or are trying to solve those problems, and how that then applies to the digital engineering that we've been talking about on this panel, that I think industry as a whole is well positioned to have some discussions on, and really make sure we're not trying to solve the same thing 2 or 3 different ways, but really taking a best of breed approach across all domains, even something as different as an open mission systems architecture and a digital engineering architecture, which to the data architect's point are actually not really all that different in the end.
All right. Well, I'm going to have to jump into the closing remarks at this point. I do appreciate the panelists coming through here, and I have to actually say I have to give a shout out to our IT side of the house here right now. I've been having some technical difficulties, so hopefully it didn't show up too badly on there. But in finishing, one of the things is I want to talk a little bit about, and it was mentioned about what Dr. Will Roper said in his "There is no spoon," and it's this digital trinity, digital engineering and management, agile software, and open architecture is the next big paradigm shift for military tech dominance. Rather than just building better system, it builds systems better, opening doors to faster design, seamless assembly, and easier upgrades. The digital world is now a primal acquisition battlefield where future wars will be won or lost. When we take this to heart, we know that every mission and capability of the armed forces and every idea and system procured by the Department of Defense is enhanced by our relationships with our industry partners. It was brought up that we can't have one without the other. There's just no way to go forward. While airmen and guardians are executing the mission with advanced systems, leaders in high-tech development like our panelists here today are using digital engineering and other advanced manufacturing methods in their processes to make those systems faster, smarter, and safer for the warfighter. They bring the best and brightest minds to bear on our requirements and deliver outstanding capabilities every day. With that, I'd like to thank our panelists of experts, Mike Atwood, Dave Duggan, GJ Miller, and Renee Pasman, for giving us some of their expert insight into how digital engineering is shaping the way we all do business. I'd like to say also, I hope everyone has a terrific day, and this concludes our panel.
Thanks, Rich.
Thanks, Richard. That was a great discussion. Thank you.
Thank you.